Yo, what's up, guys? Today I'll be trying to teach you guys about atoms the best I can, and I hope you guys enjoy this because I'll be going over different relationships of atoms. And if you guys could give me feedback, hopefully you could, and I'll thank you for that, even if that even is possible. So, firstly, what is an atom? Let's start with a very famous atom, and it's going to be hydrogen. We're going to have the blue here, the blue being the proton. This is the proton, if you see it. Then we're going to have a ring over here, and in the ring, let's say this time the red is going to be an electron. So, what do we see here? We see the nucleus, which in the hydrogen only is one proton, and there's a ring, and there's a electron. And because protons are positively charged and the electron is negatively charged, then it is not an ion because they balance each other out. There is one positive and one negative. Let's take a look at another atom. And here we're going to have two, this time these are going to be neutrons. So neutron is this color. Then we're going to have two protons. Protons are gonna be in the blue color, and then we have the ring, and then we have two electrons, and this is also a pretty known one, and this is helium. So what is important here? Firstly, we know that this scenario, the red is the neutron and the blue is the proton. It might be confusing. I might have the wrong colors with my limited options. However, these are the ones. We have protons, which are positively charged, neutrons, which are neutrally charged, so no charge, and we have the electrons, which are negatively charged. And looking at this, two protons and two electrons is two of each, positive and negative, which doesn't make it an ion because it balances each other out. So what is so important about this? You might be wondering, why am I going over the basics of electrons, atoms? And you might already understand it. Now let's look at a pretty common atom we can see all over the world. So let's let this example, the red be red is a proton. We have 1, 2, 3, 4, 5, 6, and then we have 1, 2, 3, 4, 5, 6. This is neutron. So our nucleus has in total 6 protons and 6 neutrons. Then we have the first ring, and because of the amount of electrons that can fit in one ring, there's 2 electrons in the first ring, and then it fills up. And then there's the second ring over here, which is where, because carbon it still is an atom, it has to balance the positive charge with the negative charge. So it's going to have 6 electrons in total. So we have 1, 2, 3, 4. So here you see 2 electrons in the first one and 4 in the outer ring. But there's some problem with this carbon, and that it needs to fix. And it is that it wants to fill out its octet. What does it mean by an octet? It's the outer ring. Here it can fit at most 4 more electrons. It's 8 in total. And usually it wants to have any means to get it, such as in the compound methane, which we can see in this example. So why is methane satisfying the octet rule? Well, let's say again the red is the proton. Then we have one over here, and the orbit, and they share one electron over here. And then we have another one. And another one, and another one. Each and every one of them are sharing an electron. So there, you see. Let's count this up. 1, 2 on the innermost shell, and then on the outer shell. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 in total. So it filled up its octet. And there, that makes methane possible. And it also makes the carbon satisfied in a way. And as we see here, the hydrogens are also sharing. So what is this relationship called? This is called a covalent bond, because as they were aiming to fill up the octet, they were sharing electrons together, so they could make this happen. Now, let's go over another type of bond. So erasing this thing, we're going to go over polar and non-polar bonds. So let's go to oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we have the first ring over here. 1, 2. And the second ring over here. 1, 2, 3, 4. And we need 2 more. 5, 6. And this is also attempting to fill its octet, as already previously shown. So this is actually oxygen, and a very famous compound, or it's also a gas here. It is it's the oxygen gas, the air we breathe. And to fill this octet, we get another oxygen over here, and we fill up the nucleus. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And yeah, over here, 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Yeah, 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now you see that they're sharing electrons, and it's and they both fill up their octet. However, usually there's cases that one atom makes the electron stay longer in their side. This makes one of them more negatively charged, and one subsequently more positively charged. And this is how the okay. So now we go to the next one. Now we're moving on to ionic bonds. So imagine salt. Salt consists of chlorine and sodium, and it's a chemical compound which is bonded through an ionic bond. And you might be wondering, what is an ionic bond? So I will illustrate this for you. So due to there being too much neutrons and protons in the nucleus, let's act as if the nucleus is just represented by 1 neutron and 1 proton on each one, due to the time constraints and it being strictly unnecessary in this discussion. So a sodium has 11 electrons. So what this means is that the first ring has 2 electrons in it, then it has the 8 more, and those add up to 10, and then there's 1 extra in the outer ring. In the outer ring here. This makes it so that the sodium, let's label it here, it does not actually fulfill the octet rule. So this is less happy in terms in this term. And now we're going to make chlorine. So chlorine is over here. And what's interesting about this one is that I believe it has 17 electrons. And let's illustrate them here. 1, 2, 3, 4, 5, 6, 7, 8. That's 10. 1, 2, 3, 4, 5, 6, 7. So now looking at adding the chlorine. So now, looking at the chlorine and the sodium, we notice something. In the chlorine, it's missing 1 electron to fulfill the octet rule, while the sodium is missing 1 electron also to fulfill the octet rule. Due to it being much easier to give away 1 electron than, for example, giving away 7 electrons for chlorine, what happens is that sodium gives it one electron and donates it to the chlorine, and they bond together. So imagine as if this ring ceased to exist, and now both of them fulfill the octet rule. But the problem is that in the sodium, since it donated one electron, it is more positively charged due to there being more protons. So there's a positive charge over here, and in the chlorine, because it accepted one electron, it has a more negative charge because there's more electrons than protons. So this is negatively charged. So as you notice here, one atom is negatively charged and one atom is positively charged. They're actually not called atoms now, they're called ions. And the thing is that opposites attract, and that's why chlorine and sodium are bonded together through an ionic bond, which creates salt. And now we have to go over, okay, hydrogen bonds. So water is something that we have all drunk in, I guess. Oh, sorry. And assuming we just say H2O. So we have the oxygen here, and we have the hydrogen here. And I forgot how to combine them. Wait, let me check. Yeah, never mind. It was actually very simple. My bad. You just do this. And we also have, yeah, this is O. Let's say we also have another one. We have oxygen, and we have two hydrogens. So this is a hydrogen bond, and as you can already tell, it's because of they consist of hydrogen, and water consists of two hydrogens and one oxygen. And the thing is that the oxygen likes to keep the electrons longer in its orbit, so then it becomes more negatively charged. And then the hydrogens, because their electrons got held for a longer amount of time when they were in there, then they become more positively charged. And as you know already, positives and negatives attract. So this this negative side is attracted to this positive side, and that's why the water sticks together. Okay, this is it. Thank you. Hope you enjoyed this. Bye.